Good morning, everyone. Today we are going to propose a design of the piping system for construction. Then we are from section 5, group B. There are five of us, which are me, Chai Sing, Fujin Wei, Leong Dan Wei, Bing Chi, and also Shafika.
Hey, good day everyone. My name is Siti Nur Shafika binti Muhammad Uthman, my matrix number CD230120. For this project, we were tasked with designing a water delivery system to supply water from G3 Lake to a storage tank located 10 meters above ground at SKMP construction site here at UTHM. The system is designed to deliver a minimum flow rate of 0.01 cubic meter per second, which is sufficient for key construction activities such as mixing concrete, cleaning, and curing. We use Class O PVC pipes due to their corrosion resistant, affordability, and easy to installation, making them ideal for outdoor construction environments. The total pipe length required was approximately 200 meters, considering both horizontal and vertical distance. We conduct a site visit to measure key dimensions and use engineering calculations, including Bernoulli's equations, to determine heat losses and select the appropriate centrifugal pump. This project helped us apply theoretical knowledge to a practical task while developing essential engineering and teamwork skill relevant to real-world industrial practice.
Hi, I'm Ng Qi, and I will continue to present about our related theory to our group project. So firstly, I will make a introduce again for our project and related theory. Yeah. So firstly, the water pumping system play a crucial role in the construction by supplying water for concrete, leasing, pouring, and other general site operations. And their design relies based on the fluid mechanics principle selection of pipe material, pump efficiency, and system components. Based on recent research, the choice of pipe material significantly affects the system durability and efficiency. To compare different materials and determine best options for construction water supply system, high density polyethylene, which we also know as a HDPE, and stands out due to its performance from corrosion resistance, flexibility, and strength. So it's made ideal material to fulfill the demanding conditions of construction sites. So it have the some of the related theory about in we will use to calculate in this project. Firstly is the energy equation. That is the sun. We also can know as the extending of the from the binary equations to analyze the steady incompressible flow, correlating pressure and kinetic energy and potential energy, which is also known as the elevation. The complete formulation include with the all of that the energy additions from pumping system and energy dissipation from both viscous friction and local loss, and then throughout the by 15s and above. So next is the continuity equation, which is also known as the fundamental expression of mass conservation in fluid mechanics dynamics for incompressible flow, and which also the demand density remain constant. And in this equation, which has the three element content, which is the flow rate, the velocity, and the cross-section area of the piping. So for next is the Reynolds number. Reynolds number is the fundamental dimensionless parameter for characterizing flow regions in pipe system. This formulation is also known as the Reynolds number can calculate with the density, velocity, diameter, and the dynamic viscosity in the fluid. So next is the head loss, major loss, the minor loss. The three losses in the energy equation, the head loss is the summation of the major loss and the minor loss. And major loss is known as the pipe flow system occur due to the frictionless resistance between the fluid and pipe walls. And the minor loss is the piping system occur disturbances in flow caused by the pipe fitting and components such as a valve, elbow, teeth, such as a turning point. So this is the overall, and the lastly is the head pump. In fluid mechanics, the term of pump heads refers to the energy delivered by a pump of a fluid and expressed in terms of equivalent fluid column height. So this is overall of my of the related theory Yeah, if the furthermore is present in the report for our in our report. Thank you.
So I will continue with the systems specification parts. The system is intended to support ongoing building construction activity to supplying lab water efficiently thus the carefully designed pipeline and pipe setouts, ensuring both operations reliable and cost effectiveness. This piping system is developed with simply durability and performance. It contains a water tanks, PVC pipes, centrifugal pumps, wave and filters. So for water tanks, uh, the water tank in this piper system play the important role important role to ensure in ensuring a reliable and efficient water supply for constructions activities. Uh, so for the capacity of the water tank should range around 2,270 liter, and the water tank is made out of polyethylene, which is a budget and economy types of the water tank. Uh, For the second one is the PVC pipe. The PVC pipe serves as the main conduits for transporting the water from Tasset G3 to the elevated water tank at the construction sites. PVC pipe are easy to install, require the minimum maintenance, and are highly durable. So it making them suitable for outdoor constructions environments. For the material of the PVC pipe is yeah, of course is the PVC lor. So for the third one is the centrifugal pump. For the centrifugal pump is the core components of the water pumping system. It responsible for moving the water from Tasset G3 to the elevator store tanks located to 10 meter above the ground level. So the material of the centrifugal pump is used by the stainless steel. So actually, this is more can overcomes the corrosions and so on. So for the power of the centrifugal pump is 3K watt. For the fourth is the WAF. The WAF is an important control component in the piping systems used to regulate isolators or stop the flow of the water between the circuitry and the elevator store tanks. Um, the material of the WAF is suction iron, so actually it can minimize the downtimes and preventing the potential water harmful or damage to the system components. For the last one is the filter. The filter in the piping system serve the important functions for removing the debris and the impurity from the water source from the circuitry before it enters to the centrifugal pumps. Um, for example, the impurities such as the sands, the leaf, and the sediments and so on that can damage or crops the pumps and downstream the components. By preventing this material from the entering the system, the filter helps to protect the pumps, reduce the water and tear, and prolongs the lifespans for the entire system. No? So what is the material of the filter is which is mapped by the foot grabs PP material. So that's all for the system specification parts. Thank you.
My name is Fujimena. I will present the design of the system part. Positioning the filter in front of the lake intake means that every drop of raw water must pass through its cartilage before anything travels down the long pipeline. This simple arrangement solves a huge head edge with no pre-treatment, floating debris, air gas crown, and fry steam would accumulate inside the 200-meter trench, gradually choking flow and driving headloads through the roof. Moreover, the plumb of the system is to ensure that the water was enough hydraulic energy to go through the water pipeline system. Therefore, the pump must supply enough hydraulic energy to overcome the vertical lift from lake to treatment plant and the friction loss that build up along 200 meters of pipe, fitting, valve, and the filter. That's all from me. Thank you.
Let's continue to our calculation part. First, we need to calculate the flow rate of the water. Assume that the flow rate is 0.01 meter cube per second. The diameter of the pipe is 80 mm. We found that our velocity will be 1.99 meter per second. Next, we need to calculate the Reynolds number to know that this is a turbulent or laminar flow. Since the project is conducted in Payaraja area, we need to determine the temperature of this area. Because the temperature increase will lead to lower viscosity and changes to density, so from the data we know that the highest temperature is 35 degrees Celsius while the lowest is the 22 degrees Celsius. So we use water viscosity calculator to calculate our viscosity and sub into Reynolds formula. After we get the density and also the dynamic viscosity from the data, then we can sub into the formula to find the Reynolds number. For both temperature, we get greater than 4000, so they are both turbulent flow. Since they are turbulent flow, so we use Moody chart to find the friction. Before that, we need to assume the surface roundness is 0.00015 meter. Then we divide by diameter and we'll get 0.001875. Using Moody chart, we know that the friction for both temperature, we got 0.0234 for 22 degrees Celsius and also 0.023 for 35 degrees Celsius. For the calculation afterwards, we will use 0.0234 to calculate because when friction becomes greater, the pipe will burst if cannot withstand the force. Next, we're using the energy equation to calculate the heat pump. So the pressure is zero because of using pressure gauge. The elevation and velocity are zero because of big area of water. After that, we need to find the head loss, which is the sum of the major head loss and also the minor head loss. Then the K for 90-degree elbow is 1, for 45-degree elbow is 0.4, for bow valve is 0.2, for partially clogged filter is 10, entrance loss is 0.5, and exit loss is 1. Then we assume that the velocity is constant. We get the head loss is 14.7 meter and the head pump is 26.7 meter. Next, we continue to find required power from water and also the power of the pump. After getting the power needed from the water, we estimate the efficiency of the pump, which is 90%, and get the estimated power of the pump, which is 2,900 something, which is a centrifugal pump, and it is in medium or large size pump. Let's continue to internal pressure of the pipe. We use the energy equation also. When pressure 1 and velocity 1 equals to 0, we got internal pressure 0.105 megapascal, which is accepted for the valve selection. Then we calculate the minimum thickness of the pipe to withstand the internal pressure. So it should be 0.3412 millimeter, but we selected 2.2 millimeter pipe. So the pipe can be used in our piping system.
For the costing, we focus on selecting components that offer durability and value for money while keeping the system within budget. The total estimate cost of a water delivery system is 2,754 ringgit and 50 cents, which includes a 5% contingency. Key cost items include a polytunnel water tank at 890 ringgit, PVC Class O pipes at 270 ringgit, and a centrifugal pumps priced at 980 ringgit. Other components such as valve, filter, pipe elbows, and fitting make up the remaining costs. This budget ensures we meet the performance needs of the system without exceeding practical financial limits. That's all from me. Thank you.
So I will make a summary and conclusion for our project. In this project, accomplish the development of an effective water transfer system that diverts water from Dasej 3 to an elevator storage tank at the construction site while fulfilling all technical specifications. The implementation incorporates high-density polyethylene piping, a centrifugal pumping unit, and engineer fittings to achieve an optimal balance between the system longevity and economy feasibility. From primary design, construct involved the maintaining cost efficiency without compromising performance, which was resolved through carefully material section and component optimization. So the ongoing the academic supervision contributed significantly to enhancing the system precision and operation effectiveness. The ultimately delivering a dependable water supply solution of a critical construction operation, including the concrete production and feasibility upkeep. And yeah, the potential system upgrades may incorporate inter-region monitoring technologies and predictive maintenance features to enhance the future operational reliability and performance metrics. And that's why we do this project and make the calculation for the head loss, the minor loss, the pressure loss, and other things to make sure the energy efficiency is enough and which is is efficiency. So thank you. This is for our project. Thank you, everyone.